Alkali of metals group 2's elements. The position of the alkali of metal in the periodic table is second column from left. Elements in group 2 contains beryllium, magnesium, calcium, strontium, barium, and radium. Chemical reaction of alkali of metal. Reaction 1. Reaction with oxygen OA. The alkali of metals can react readily on heating with oxygen to form oxides. Here is the general chemical equation by which M is the alkali of metal. The peroxide of heaviest metal can be obtained on heating the normal oxide with oxygen at high temperature. Here is the example of chemical equation when barium oxide reacts with oxygen. Example, reaction of magnesium with oxygen. Magnesium reacts with oxygen to form magnesium oxide. Here is the short video clips for this reaction. From this video, we can observe that magnesium burns very vigorously and bright white flame is formed. Also, white solid which is magnesium oxide is formed. Reaction 2. Reaction with hydrogen. Calcium, strontium, and barium can react with hydrogen to form crystalline metal hydrides. Here is the general chemical equation by which M is calcium, strontium, or barium. The hydrides forms can react readily in water to give hydrogen gas. Examples: reaction of calcium with hydrogen. Calcium reacts with hydrogen gas to form solid calcium hydride. Calcium hydrides react with water to form calcium hydroxide and hydrogen gas. Reaction 3. Reaction with nitrogen. Alkali of metals form nitride on heating in presence of nitrogen, which are hydrolyzed by water to give ammonia. The first equation is the equation when metal react with nitrogen gas, while the second equation is the equations when metal nitride is hydrolyzed by water to form ammonia. These reactions cannot occur in ordinary conditions. Extremely high temperatures are required for this reaction. Examples: reaction of magnesium with nitrogen. Magnesium reacts with nitrogen gas to form solid magnesium nitride. Reaction 4. Reaction with water. Alkali of metal react readily with water to give hydrogen gas and metal hydroxides. Here is the general chemical equation by which M is the alkali of metal. It is not that beryllium and magnesium do not react readily with water due to their low reactivity. Examples: reaction of calcium with water. Calcium reacts with water to form calcium hydroxide and hydrogen gas. Here is the short video clips for this reaction. Reaction 5. Reaction with halogens. Alkali of metals react readily with halogen to give metal halides. Here is the general chemical equation by which M is the alkali of metals. Examples of halogens are fluorine, chlorine, bromine, and iodine. Examples: reaction of magnesium with chlorine. Magnesium reacts with chlorine to form magnesium chloride. Reaction 6. Reaction with acids. Alkali of metal react with dilute acid to form corresponding salt and hydrogen gas. Here is the example of calcium react with hydrochloric acid to form calcium chloride and hydrogen gas. This is the short video clip for the reactions between calcium and hydrochloric acid. Halides. Beryllium halides. Beryllium halide is a covalent compound. First, beryllium fluoride. It can be prepared from thermal decomposition of ammonium beryllium fluoride. Next, beryllium chloride. It can be made from the beryllium oxide. The chloride as well as beryllium bromide and beryllium iodide can also be prepared from direct reaction of the elements at elevated temperature. Anhydrous halide of magnesium. It can be prepared by the direct composition of the elements. For calcium fluorides, it is the most important fluoride of group 2. Its mineral form fluoride of fluorspar is the only large-scale source of fluorine. It can be prepared by action of concentrated sulfuric acid on fluorspar. Magnesium chloride and calcium chloride are used to de-ice rocks due to: first, the solution is very isothermic, by which the enthalpy change of solution is negative at 2 kJ per mole. Second, calcium and magnesium chloride are less toxic than sodium chloride to plant life surrounding rocks and are less corrosive to iron and steel. Hydrides. Metal except for beryllium react with hydrogen to form ionic hydrides by using direct reactions method. Since beryllium hydride is covalent, thus it must be prepared from alkyl beryllium. Then ionic hydride of the heavier element can react with water to form hydrogen gas. Here is the example of chemical equation between magnesium hydride react with water. Function of magnesium hydride is: it is an excellent hydrogen storage material. For calcium hydride, it can be used as desiccant for amine solvents. Oxides. Group 2 elements react with oxygen to form oxides. Then, except beryllium, all group 2 elements can form unstable peroxides. The oxide of group 2 elements, except barium, can be obtained by direct combination of the elements, but it is most commonly obtained by decomposition of the carbonates. Here is the general chemical equation. Sulfides. Barium sulfide adopt a zinc braid structure, whereas sulfide of the heavier elements adopt rock salt structure. Barium sulfate produced by reducing the natural occurring barytes with cod. Hydroxide. For metal barium, barium hydroxide can be produced from the reactions between aqueous solutions that contain barium ion and sodium hydroxide. For the metal other than barium, metal hydroxide can be produced from the reaction between its metal oxide and water. Nitrides. When alkali of metal is heated with nitrogen gas, it can form metal nitrides. Then, metal nitride can be reacted with water to form metal hydroxide and ammonia. Carbides. All the alkali of metals form carbides. Carbide of calcium, strontium, and barium can be formed by heating the metal oxide or metal carbonate with carbon in a furnace of 2000 degrees Celsius. Here is the general chemical equation. The first equation is the metal oxide react with carbon, while the second equation is the metal carbonate react with carbon. All the carbides react with water to produce the hydrocarbon. For barium carbide, it can produce methane gas. However, for elements other than barium carbides, it can produce ethyl gas. That's all from me. Thank you.